Hello, everybody. Welcome to OpenCV Weekly Webinar. And today we have with us Gerard Espona, who was one of the competitors of OpenCV AI competition last year. And he did some great job with Unity plugin and OpenCV AI Kit. And today we are very happy to announce that he has joined in official capacity with the Luxonis team. And now we are working on more and more on Unity. So Gerard would give us an update, cool new things that you can do once with deep learning, machine learning in general, and Unity. So we'll learn a lot in this webinar. Welcome, Gerard.
Hi, and yes, thank you. It's a privilege to be here today to talk about the Oak for Unity. So
that's great.
It's always fun.
And also with us is Phil Nelson, who is the content manager at OpenCV, and he's responsible for putting all these webinars together, among many other things. Welcome, Phil.
Yes. Good morning, everybody. As Satya's right, as he likes to say, it's all my fault if something goes wrong. And if something goes right, obviously it's Satya's fault. If this is your first time joining us on OpenCV Weekly Webinar, if you just need a reminder, we do a little something here every week, which is a special giveaway for those of you in the live Zoom audience. So stay tuned for that at the end of the webinar. Also, we use the Zoom Q&A functionality. So down in the corner of the screen there, at any time during the webinar, if you've got a question, you can ask it using that, and we'll do our best to work it into the flow of conversation or save about 15 minutes at the end for your questions.
Yeah, and today we do have 15 minutes, we can assure you.
fingers crossed.
Fingers crossed.
I'll do my best, but...
All right, let's get started. Gerard, it's your show.
Cool, thank you. Let's share the screen first. So, could you see my screen? Hopefully, yes.
Yes.
Yeah, it looks good.
So, yeah. So, well, first, hi to everyone, and thanks for joining this session. And again, thanks for this opportunity to be here. It's always a privilege to talk about Oak for Unity. So, well, my name is Gerard Espona. I'm software developer and with some computer vision AI background. I don't see your faces, so now sharing.
You're good.
So, and today the session is about what's new with OpenCV AI Kit and Unity. And there is a lot of news. So we'll try to keep everything under 40 minutes with some demos. So we'll do let's try it. So
just a little addition I want to add, that people who are looking for synthetic data in deep learning applications, AI applications in general, there's a lot of effort Unity is putting in to bring the deep learning community, the AI community in general, so that they become the platform where all the synthetic data is generated. There are many other platforms also. For example, Carla is for car simulation, but Unity, for general purpose, Unity is taking the lead. So we are glad that Oak is also in the community.
Yes, definitely. So yeah, today, well, with the limited time, we'll do our best to go through some of these tools to help people on computer vision AI. For example, they want to train their own models. So synthetic data sets will help for sure. So on this task. So, okay, so first, anyway, I want to give some context for all of you to understand, why we started the development of the Unity plugin. So, as Satya said, last year we were here also talking about creating robotic digital twins with Unity. That's why it was the core of our proposal for the OpenCV Spatial AI contest. and proudly we become finalist. And our robot called Cauda is open source, 3D printable, low-cost 5-axis robotic arm designed by Giovanni Lerda. And my part is the software part. So we thought to take Cauda to the next level thanks to spatial computer vision AI. So we designed two applications with two OTs, one for safety and collaboration. So basically one OT camera is monitoring the robot working area. And when a person comes in, it's pausing the activity, enabling safety and collaboration. And then the user can resume the activity with hand gestures, for example. Then for the robot itself, we design a simple dynamic touch task using an object detector plus inverse kinematics. So just to push a bit the boundaries, we designed the inverse kinematics as a reinforcement learning task. So Cauda was learning how to perform inverse kinematics.
That's great.
And then we put everything into Oak.
Just a little background. So people who do not know what a digital twin is, basically in robotics, it's a concept where people, if you have a robot, and you want to program that robot, it's not always possible for you to have that robot connected to your system or even have access to the robot if you have, let's say, a team working remotely and not all the team members have a robot. It's almost impossible to develop. So people came up with this idea that you can create a digital twin for your robot. So it's a software twin. It will work exactly like the robot does. Of course, in real world, there will be some differences, but the idea is that you can use these digital twins to do most of the programming and then, fix the corner cases with the real robot. So that's the whole idea of digital twins. And that is something that Gerard and his team had implemented last time.
Yes, yes. So in the last webinar, we will go in deep in the concept. Today, anyway, we will see anyway some examples. But yes, basically that's the idea. So, and has a lot of benefits. So you have a virtual robot. That's the point. So it should be an accurate simulation of the real robot, just because when you move from simulation to real, you don't want to have then strange behaviors or a mismatch. But that's the basic idea. So you have a virtual robot inside Unity, and you can leverage this simulation for training, like we did with the reinforcement learning, and also I will talk later. You can combine with the synthetic datasets. But yes, so this is a bit all the work we did during the contest. I'm not going in deep, but I want to highlight. I think when we did the first webinar, we just presenting this bus driving in virtual city, doing the tiny YOLO. Yeah, I just want to highlight two things here. The Unity plugin itself. So obviously we needed the connection between Oak and Unity because the digital twin lives in Unity. So it was important to have the connection. And then after we go a bit more further and we develop the virtual sensor. So we develop a virtual Oak camera to complement the digital twin. That's important because it's in fact is what it unlocks these other kind of applications, simulation and synthetic datasets. But yeah, anyway, if there is a lot of resources, if someone wants to check more in detail all this work, I will leave the links. At this point, but I want to thank Anthony Navarro from Unity, because after the contest, he contacted us and was publishing this kind of interview summary of the project. So you can see here more easily. So this is Cauda robotic arm. And then you can see here the virtual oak cameras. And for example, you can check some of the reinforcement learning work. And this is a good example. So this is the digital twin. So this is the virtual robot simulation. And here we leverage to scale and speed up the training. So you have a bunch of robots training at the same time. So you speed up in the training. And then you can compare, for example, the inference on host and inference on oak right beside. So this is this is one thing. So there are many benefits on the digital twins. Obviously, you can create a lot of copies, and it's much easier to work with virtual robots that usually with real robots.
Definitely a lot less work for the 3D printer.
Right. Yeah, definitely. So, okay, and also, for example, you can see, talking about the synthetic datasets, you can see here an interesting experiment. It's kind of end-to-end pipeline to train a custom YOLO category, but using only synthetic datasets. So the custom YOLO category is this serial box. So we were generating datasets to train.
Could you
YOLO.
make it full screen? Could you make it
full
screen?
Sorry.
Yeah.
Maybe I can.
Yeah, start again, because that's very interesting. The top view, top left. Yeah.
So so basically here you can see the steps. So this is the generation of the. So you need this 3D model. This is the serial box. Then we can see over here. We using this 3D model, we can generate synthetic datasets. So for that, you can see some examples here. So for that, we randomize. Obviously, we want a dataset representative, so you need to generate variability on each capture, adding background objects, occluders, changing lining conditions, everything that helps to have a good dataset for the training. And then you can see some results over here at the end. So recognizing the serial box. So, well, so, and then finally, of course, there is this, our final video submission where you can see the digital twin connected to the real one doing the dynamic touch task, and then the collaboration and safety part. So, okay, so that's the, that's the what I want to show you about the context. just to understand a bit why we started to develop. No? So now the question, so what is Oak for Unity? Well, I think now it's easy to explain. So just a plugin for Windows, Linux, and Mac to enable this connection between Oak and Unity. The thing is, as you see, and also in the spirit of this plugin, you can combine Oak and Unity in different ways, in fact. So that's why we split it in two parts. One, we call it Oak for Creators. It's kind of a high-level API. So it's basically for Unity developers without machine learning knowledge, let's say. So they don't want to develop custom pipelines. They don't want to train custom models. So they just want to use pre-trained models to develop applications, video games, or interactive experience with depth, hand tracking, body pose, head pose. So
yeah.
this kind of pre-trained models. And then we have this second part. We call it Oak for Computer Vision AI Robotics. So, and it's based on this virtual sensor, this virtual Oak device, and okay, helping to these users that probably they want to train their own models using synthetic dataset, for example, or probably if you are on robotics, probably you also are in ROS. So there is an integration between Unity and ROS to have an accurate simulation of the robot. You can speed up on these iteration cycles using your digital twin. And also you can send images to Oak and evaluate models like the virtual city. So, but let's start with Oak for Creators. In fact, this is the most visual part, or more creative and probably more fun also. And that's why we decided to start releasing this part first in the GitHub repository in a beta testing. So we have a list of pre-trained models we want to deliver, and we call it this set like version 1. And the idea is when we reach this version 1, we will publish the plugin also for free to the Unity Asset Store. So it will be more easy for the Unity community to get the plugin. And by the way, I want to call everyone to join the beta. So here again, there are a lot of resources to stay tuned on the progress. The best one is go to the repository and start follow. So I invite everyone to do it. What you're going to see if you go to the repository. So if you are on Windows machine, you have available right now the device manager, the demo menu scene, the typical device streams with color, stereo, depth, and then a set of point cloud visualization using visual effect graph. And I want to thank here to Keijiro Takahashi from Unity Japan from his amazing work on this part. And also allowed us to integrate all this work on the Unity plugin. So you will see soon in a demo. And then you see here in the list all of these pre-trained demos, let's say, or pre-trained model demos. Object detector, face detector, body pose, head pose, face emotion, deep lab, and hand tracking. So still not yet in the available in the repository, but you will see. So the good news is all of them are developed. So it's just matter to push to the repo. So you can expect having really soon. Okay. And this is more or less the version 1 of Creator. And then, yeah, for the first demo, my idea is to show how easy is getting started. So, so this is the official repository. So the FII Unity. And in fact, if you are on Windows, you don't need to do too much. Really something special. Also because to make it easy, we under this folder OAK for Unity, you have this universal render pipeline Unity project. So you have everything here. So you just need to open, so clone the repo, of course, and install Unity, and then open this project. So you under OAK for Unity URP, and you will get something like this. So under the folder plugins, you have OAK for Unity with everything you need. But also to make it more easy, you can go here in the menu, click OAK for Unity, example scenes, and now let's see if that's better. And now I have an OAK connected to the PC, so I just hit play, and this will, yeah, so this is what we call OAK Playground, and yeah, so basically this is kind of a good entry point to check all the demos. You can check if you have an OAK device connected, and then you can find what we talk about, the basic streams, point cloud, visual effects, and coming soon the rest of pre-trained models. So you can navigate also through the arrows, and for example, the basic streams. Hello. So you can find the typical left, right, color, disparity, depth. Then about the point cloud, you can find this. This is the classical point cloud demo, and some more fancy effect, adding this visual effect graph. So
obviously that's everybody's favorite. It's definitely the coolest looking demo on there.
Yes. And the credits. This is just a small tweak on the work of Keijiro, but all the credits for Keijiro. It's amazing his work on visual effects and so on. So and
extremely cool.
Yeah. So that's the thing you can find today. But as I Okay, yeah. As I as I was explaining, you can expect all the pre-trained models really soon. I want to show, in fact, some examples, but really, yeah, here is about creativity. So, yeah, can't wait to see which kind of applications people will do with Unity. So let's see. So again, yeah, calling everyone to join the beta. And so here, yeah, again, just few examples. So for example, this one is the hand tracking plus depth. So, and then you can see, yeah, the virtual hand going here.
Yeah, who needs the power glove?
And with some, yeah, with some hand gestures, then, yeah, messing with this fluid simulation.
So you're able
Another
to,
example.
there is a real component which your hands are now becoming almost like the controller, and you have the virtual hand in Unity as well, right? Once the OAK is connected with the plugin, you can track body and hand and other things just to, and then control the environment using your virtual hand.
Yeah, exactly. So I'm missing a small part here. We call it OC for developers also, in fact, but there is a lot of utilities also for the normal workflow. Also, for example, if you develop for VR, for example, yeah, you can track hand, body to help to speed up in the workflows. But yes, then you can integrate with many assets. In fact, that's the good thing of Unity. Yeah, I'm going to. So yeah, and more examples. So you can see here, this is the face emotion plus depth. So the camera starts when you, this is kind of a photo booth demo. So you can see with the depth, it's asking me to get in the right spot and then smile for get this perfect photo.
Or if you're
Yeah.
an MMA fighter, you have to scowl, right? You can't be smiling at your press conference, you know.
Yes, maybe.
Yeah, you could also be developing, in a game, your character could be actually responding to your emotions.
Exactly. Yeah. Yeah, exactly. That's a bit the idea over here. So you can see the character is, well, it's mimicking my emotions, and then when it's angry, it's doing this damage. But definitely here the possibilities are endless. So it's just a few ideas, but just the top of the iceberg.
Mm-hmm.
So, and not combining, you can combine then some of these pre-trained models. So will be really fun. These are more examples. This is a funny experiment with head pose. Just going a bit different, and yeah, this one is controlling this Nautilus with also head pose, and then I think there is an old demo. Yeah, this one, the first demo with face detector controlling the airplane. So
I remember when this first demo with the plane dropped on on LinkedIn, and I was like, of all the things I expected to see today, a guy controlling a plane with his face was not one of them. And yet
Yes.
here we are.
Yeah, exactly. So
So
yeah,
the thing
anyway.
that I really like about this is that in many games initially, there was a company called Leap Motion that allowed you to, track your hands very accurately. And that's great. But, if people want other functionalities, other modalities of having a controller, then that's even better. And this is what it's doing. So yeah, I'm really excited how people are going to use it.
Yeah. Yeah, and that's the thing. Also, then you can combine, you can switch from, I don't know, from one modality to another at I don't know, at the middle of the game. You can ask different kind of interactions, or for interactive experiences also.
Yeah.
And this
Um,
one, the
There's
last one,
also a lot of one thing we haven't mentioned here is that with the pandemic and in situations where you don't want people to be touching things with their hands, this kind of control is extremely useful in terms of mitigating the when you have to be out in the world. It's much safer to be able to use these gestural interfaces than to have to physically touch and then sanitize surfaces.
yeah, definitely. Yeah, here we are very focused on video games, but interactive experiences or even spatial AI applications. Why not? So yeah, and this one is the using body pose estimation. So playing this green light, red light game. So it's just an example. So yeah, so that's the part. Okay, so yeah, so that's the first part for creators. So again, um, everyone is welcome, or more than welcome, to join the beta. And now, yeah, I want to talk a bit on the second part. So opt for computer vision.
One question for me is,
Yes.
what's your current thinking on, so what can people expect if they try out this beta? Is there going to be like some kind of cadence to the releases? Are you targeting a specific launch day for having the Unity package ready or anything like that?
No, not really. We don't have a hard deadline. It's just we thought that people can enjoy gradually. So in fact, we have we kind of sort the pre-trained models according some feedback we got from the community, and we thought, yeah, makes sense to release and get things on the hands of people without waiting to have a perfect version 1, whatever. So it's more
Yeah, that
about,
totally
yeah,
makes sense. It sounds like if people show up and try this out, they'll actually really have a hand in shaping how this thing is developed as well.
yes. So that's the main idea behind the beta testing, but no, nothing further. There is no huge requirements on equipment or something. It's just inviting people to start playing with the plugin. There's no, yeah, nothing else. And all the feedback that we are getting, that is very useful for us. So yes, so then I think we can jump to the second part. Again, this second part is maybe, yeah, more low level, but here we started to integrate this virtual sensor, so the virtual O camera, with some tools that Unity is pushing forward to help on computer vision. So again, with simulation and specifically with robotics simulation. So if you are on robotics plus ROS, there is very good resources here. And then with the synthetic data sets. So the long term here for the Unity plugin is to provide also good workflows. So to make it easy. So today is kind of, well, we start to integrate with all of these tools, but it's early stage and using each tool could be complex. So we want to make it easy for everyone. So today, because the time going fast through them, so we don't have time to go in deep, but so please to maximize maybe. So you have a Unity Simulation Pro. This is a special version of Unity, headless version that you can deploy on the cloud. It's basically to scale simulations. So you can see here a virtual city, or you can see the Turtlebot going around a warehouse. Then you have Unity Robotics Hub. This is interesting. So if you are on robotics, I want to highlight that the Oak has support for ROS. So in fact, you can run Oak pipelines inside the ROS stack. And I want to show here, for example, how it works, this integration.
So for people who do not know, ROS stands for Robot Operating System. It is basically a framework which people use for developing applications for robots, or for even controlling the robots and everything. So if you are starting a career in robotics, or if you're starting developing for robots, knowing ROS is almost a requirement. So let's say it's, if you're familiar with OpenCV is the default library for computer vision. Just like that, for robotics, ROS is the default framework you need to, or library that you need to learn.
Yes. So yes, exactly. So in this example, I want to show you. So you have this virtual robot that also you can import from URDF. That's the kind of robot description standard format. And here on the right, in fact, you can see is I'm running ROS in a Docker image. So, and basically what you can see over here is this robot at the end is doing a pick and place task. So what I'm going to do is publish to ROS what is the position of this cube, and ROS is going to compute the movement plan to do the pick and place task. So at the end, what is happening here is that this ROS part is exactly the same you are running on the real robot. So really here you can have an accurate simulation. So the moving from simulation to real after should be easy. And the connection is happening thanks to a TCP connector here. So this is one tool interesting for anyone working on robotics. Obviously benefits, you can speed up again on development cycle using your virtual robot. It's an accurate simulation. Oak has support for ROS, so you can integrate Oak pipelines without any issues. And then you can also anyway send images from Unity to Oak run the pipeline. And then let's say you are on robotics and probably to solve some real world problems. So probably you want to train your own model. So let's say you are building a robot, let's say moving around the living room. And let's say you are interested to detect the tables, okay? So usually the process is, well, you need to capture images of the table, annotate the table manually to train your object detector, right?
Yeah.
The thing is, you want your robot to work at every home. So there is a lot of types of tables, a lot of materials, sizes, and so on. And then you want your robot to work fine at every hour of the day. So in order to have a real good data set, then you need to capture this variability on the light conditions during all day long, probably with artificial light also. And then on top you have the chairs that's occluding your table and so on. So and here is where synthetic datasets could help you to create these kind of datasets. The thing is, the captures of these images are generated by Unity. So that's why it's called synthetic. You generate usually using these photorealistic scenes. So, and because everything is inside Unity, of course, there is all data. All the data is there. So the first thing is Unity can label for us automatically. So we don't need to label, to annotate the objects, because Unity can do it for us. It's what is called ground truth automatic labeling. So like in this example, you see the 3D bounding box or the segmentation. And the other interesting thing is inside Unity is really easy and easy to scale to create this variability. So it's easy to randomize the time of day, for example, or the materials. So for example, you can see an example here.
Could you do full screen?
Yes.
Yeah.
So yeah, it's a short video. So here, in each capture, you can parameterize how you want to random light conditions, objects, materials. You can randomize almost everything. And yeah, so you can create big data sets much easier than probably in real life. So I want to show here, for example, we extend to get the ground truth depth. So, and here I want to show you, in fact, the virtual sensor. So here we have a virtual oak. So you can see this is the virtual city environment, and you can see here the left and right virtual images, the color one. This is the ground truth depth, because obviously in Unity knows exactly the perfect depth of every point. So, but this one is we sent the virtual images to Oak, and we compute the real disparity, let's say, or the Oak disparity. So you can see, well, first you can see the type of labels you can get automatically using Unity. So you can get 2D bounding box, 3D bounding boxes, and then semantic segmentation. And we don't see here, but you can get also a human body key points. And then these examples, what I was commenting, so to get ground truth depth plus the real disparity, for example. So, okay. So benefits using synthetic datasets, accuracy. So you can generate big datasets and really fast, and you can scale very easily. But also you can complement, for example, real datasets with rare cases. So that usually will take you very long time to collect in real world. About the cost, obviously human manual annotation is time consuming. So having these ground truth labelers are really, really good. You can, thanks to the randomize, you can create really big diversity of data. And then of course you can even make short your iteration cycles when you're training your own model. So at the end, in long term, the goal here for the Unity plugin is just to make easy all of these workflows for any Oak user. So provide a complete set of randomizers, make more easy to set up scenarios and strategies for synthetic datasets, provide a set of publishers, subscribers for Oak ROS integration, provide support for cloud, then you can really scale in simulations, and provide better sensor simulation. So yeah, so that's also part of the work we are doing. And just to finish, because at this point maybe it's still difficult to okay, how to apply all of these concepts to a real use case. So we are lucky because I can share with you a real use case thanks to Grenzi. It's just a very initial work, I think 3 weeks, 3 weeks work. But well, first I want to thank Grenzi allows us to share all this work, and yes, and also to recognize the value of synthetic datasets and digital twin in midterm that sometimes is not easy to see. So, but well, what is Grenzi? I think the best is to see this video.
Tractor sounds like it's trying to sell me an iPod.
Yeah. So, yeah. So, well, I think it's easy to understand. So Grenzi is adding self-driving capabilities to commercial mowers. It's very interesting. It's ROS powered. So, and the next versions will deploy Oak cameras to perform person detection and no grass class segmentation to help avoiding obstacles. So trees, cones, drains. So basically, these custom models will help to increase the autonomy of the robot and to speed up on and help on that. They are leveraging on digital twin also, so in simulation and synthetic data. So as you can imagine, there is a lot of challenges. So you have deployed mowers around all US. So collect data from real world, how to really make short the iteration cycles, how to collect maybe some specific data sets, persons close to mower, for example, or collect rare data sets with enough volume, how to evaluate changes, how to improve machine learning models. So there is a lot of challenges here, and how digital twin could help on that. So first, generate using synthetic datasets. So we are starting to use automatic labeling for semantic segmentation for the grass. Also, we will create datasets focused on persons close to mower without the risk, because in Unity there is no injuries. And then with the randomizers on obstacles, background objects, time of day. But also we can, with Unity, we can help with the sensor simulation. So help with new designs when, because we have, for example, oak with white angle. So we can simulate and see the impact in Unity. Also, we can evaluate models directly on the virtual environment. And thanks to the ROS integration, we have then an accurate digital twin. And on top of that, we are creating Unity scenes based on real locations with challenging elements. So Grenzy knows that this particular location has some challenging elements. So I want to show very quickly how we are helping on this topic. So we created this initial scene to evaluate the semantic segmentation. So here you can see this is the URDF import of the robot. So with the wheels, with some sensors, IMU, GPS, and the blades. And then we have this scene. So this scene has obviously grass, and then some obstacles. So here we have some rocks, some fences, some trees, and then we have this guy. So the goal is generate a data set doing the segmentation on these three categories. So if I'm hitting play,
The moment of truth.
yes. So you can see maybe like this better.
Yeah.
So green is grass, blue is sky. So, and then you have black is the obstacles, let's say. And you can see if I'm moving the camera around. So I'm getting this segmentation in real time. So and then we can check here the data set. So for example, in this short period of time, we created 700 images with proper segmentation info.
Very cool.
Wow.
Yeah, so, and as a bonus, honestly, this was not at all the idea. I can show you some results, in fact, from yesterday or 2 days ago. But I want to highlight that was not the intention, because we created just a small data set of just only 80 images without any randomization at all, just to put in place the pipelines. But then Matija, the person working with the models, decided to give a try. And as you can see, it's going to be far away from perfection. So, but because you can see, for example, this is a real video sequence.
Yeah.
So obviously, this is failing. So this
Right.
is grass. You can see the segmentation here is not perfect at all. So yeah, so the sky here is failing a bit.
Right.
You can see it's far away from perfect, but well, really,
it's great to be like, you know, honest about and show these things from the start too, because
80
obviously
images, 80 images only, right? That's
it's
pretty exciting.
yeah.
Of course, it's
80, yeah, exact. That's the point. 80 matches without any kind of randomization. In fact, I was like very, very, yeah, for me it's incredible. So even this is, yeah, so at some point the trees are working pretty well, in fact.
Yeah, and not just 80
some,
images, but 80 synthetic images on a real life scene.
yeah,
To do this well as a first try is pretty dang cool.
it's yeah, it's really promising. So you can imagine, I mean usually, I don't know, I can generate 100K images in few hours. So
yeah.
with proper randomization, I mean, it's so this is good example of, okay, you can see the sky is failing here, segmentation here is not perfect, this is not grass, and this cone, yeah, more or less. But yeah, but in general, you can see.
Right.
You
And
can see.
the other thing is that, you know, sometimes in some applications, you can actually create good results by overfitting to the model. You know, usually in deep learning, and we don't want overfitting. We want our models to generalize, but that's only most of the time, right? There are certain cases where you actually want your model to overfit. For example, you're creating an application where it is for a very specific setup, right? So let's say, you know, you're building in a manufacturing environment, right? You are in a manufacturing environment, you know that things are going to be constant, right? In that case, you don't want to build a general purpose object detector. You may actually have an object detector specifically for that particular environment, right? Now, in your example, for example, you could think about let's say it's a golf course or something. I don't know what that scene was, but let's say it was a golf course, right? In that case, these are big properties, and you know, a single uh, lawn mowing contract would be, I don't know, $100,000 a year or something like that, right? It would be expensive. So you might as well create things specifically for them, right? So of course you have a general model, but then you overfit on their data by creating these synthetic data sets specifically for their particular, golf course. And
That's
that
that's
can actually boost up performance for this specific golf course quite a bit.
yeah. That's exactly the approach, in fact. So I had no time here to show more about the strategy for the obstacles, for example, but
Yeah,
Grenzi has very clear. So
yeah,
what are the type of common objects you can find? So it's not about to create some crazy general model maybe for everything, because it's true. It's and that's why, for example, we started to create Unity scenes based on real locations.
yeah.
So Grenzi has located some real locations from customers that have some particularities, some challenging items. So we use them to simulate and to improve on these examples also.
it's also fascinating how quickly this idea has has been taken up. For example, we had Scythe Robotics on our show earlier, and Green is another company. There's another company we are working with, I cannot talk about, which is also in the space of outdoor
Autonomous
lawnmowers.
lawn care.
Yeah.
Yeah, and they're all slightly different. They're all they're taking slightly different approaches. Sometimes, like Scythe Robotics is building its own robots, right? And this company that you're talking about, I don't know whether they build their own robots or they are actually. There are some other companies that are not actually building their own robots. They're using existing robots and upgrading those robots to work in a general case, right?
Well,
But this idea of autonomous robots is taking off in a big way, I would say. I mean, earlier, if you think about it, just 5 years back, the only autonomous robots we saw in daily use were the Roombas, right? And they were also pretty dumb. They were based on this touch sensor, and they would just go randomly around the house, bumping into everything, and finally figure out the structure of the house.
Sort of like me first thing in the morning.
but now these are smart ones, right? They are actually analyzing the scene. So I'm very bullish on robotics, like computer vision for robotics. So
Yeah, sorry to interrupt this very interesting conversation. We still got to do our giveaway. We're past 10.
Let's do it. Sorry. I'm sorry.
It's okay. So if this is your first time joining us, this is we do a giveaway at the end of the show here based on a trivia question generated from the slides earlier in the webinar. So if you're in the Zoom chat, you'll be able to answer this question, and the first one to answer this question in the Zoom chat window will win. Would you like to tell them what they'll win, Satya?
Yeah, you will win an Oak D light. I usually have it on my table, but I cannot find it right now. But Oak D,
I got one. I got one right here. Look at this guy. It's even got the bumper case on it. Yep.
Yeah. So it's a depth camera with neural inference. It's a spatial AI camera that it's the little sister of Oak D that Gerard was talking about. So great camera.
Yes, exactly. And so if you've recently won our trivia giveaway, please do not answer. Let other people have a chance to win here. I'm looking at you, Partha. So earlier in the webinar, Gerard showed us a couple of different robots using this technology, one of which was a little small robot that is ROS powered, not the lawnmower. What is the name of that little robot we saw earlier? Oh, we got one already. Turtlebot, David Wheeler is our winner this week. David, please send one email to phil@opencv.org, and we will make sure that you get your Oak D light. Congratulations.
Congratulations.
Do we want to do like one question since we kind of went over a little bit today? Had a couple of good ones in the chat here. Dale would like to know, does the Unity plugin simulate we've kind of already answered this by demonstration, but I don't think we were explicit about it. Does it simulate the RGB, mono 1 and 2, disparity, and depth feeds? And does it include any way to, say, generate noise in a more real-life way than you would normally get under a simulator?
Yeah, well, that's a very good question. So I can explain. So currently with Unity, you can simulate pretty good the camera kind of parameters, physical parameters. So you can, there is even a kind of a physical camera where you can go deep on some parameters, like, well, easy ones, field of view, but even you can go to the sensor size and so on. But there is some limits, okay, for this. So currently in the implementation of the virtual Oak, I'm simulating the 3 cameras, of course, the right, left, and color with the specs of the real camera, of course. But about noise, and going more. And so, but for example, you cannot yet simulate directly disparity. For example, real oak disparity. So that's why in my example, what I was doing was sending the virtual images to the real oak and compute the disparity there. I cannot share too much on it here, but we are working close to the Unity Robotic Hub because they are working a lot in deep simulation of sensors. And I cannot share too much because there is an NDA and so on. So there is a close collaboration here. So that's why in more midterm, I added this improved sensor simulation on the roadmap, because I expect, yes, you will have a real simulation inside Unity of disparity and more, difficult
Real
things
life is
to
very
simulate,
noisy.
like noise. Yes.
Yeah.
So
Thanks. Well, I think we got time for one more. Murat would like to know, where would you tell people who are looking to just get started with synthetic data, where would you send them to start from scratch if they have a little bit of knowledge about machine learning already and maybe know some code? Where's the best place to learn, in your opinion?
well, I would say, it's difficult also to answer. I would say, anyway, the first place to see is the repo of Unity on computer vision, and they call it perception package. So they have some good examples, and I think I have the link over there. So for example, to train, they have an example to generate a synthetic dataset based on supermarket items, for example. Recently, Unity team released also another project for a human annotation for call it peoples and people, where they randomize a lot on persons. Okay, both are good projects, so you can download the Unity project and run by yourself. There is some documentation. Anyway, I want to advise that it's kind of an early stage. So Unity Perception Package is still alpha, so in preview mode, whatever. So, but it's a good place to start to see some examples how they randomize, for example. So when you hit play and they start to generate these crazy images, to understand how they randomize the parameters for that. I would say this could be a good place.
That's great.
Awesome. Yeah, thanks for that. It's 10:10. Satya, you want to take us home?
Yeah, thanks a lot, Gerard. This was a fascinating talk, especially the last 20 minutes or so. It was eye-opening. And I like to say that people, if you want great careers, you should be working at the intersection of two fields. But here, with this thing, there are three fields taking off. One is artificial intelligence, AR, VR, and robotics. These are all in sync. They are, I believe that they are all three of them. The time has come that they are all taking off. And if you work in this area that Gerard just explained, it is the intersection of all these three things, which, if you develop skills in these three things, it's going to be a great career. You'll have not only great career, you'll also be working on fascinating, interesting stuff. So yeah, get your hands on this. Thank you so much, Gerard, for this illuminating us with all the various tools available, all the various techniques. And thanks as always, Phil, for organizing this. And last but not the least, thank you, our audience. It really means a lot to us that you guys show up every week and we have something to say, something to share. That's it. Thank you so much.
Thanks, everybody. Join us next week for part 2 of our Snowman Detector / History of YOLO, hosted by our own Dr. Satya Malik.
All right. See you next week.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision from the experts at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.